Welcome to this session on cell widgets in the wild. My name's DiGiano, and I'm from Google, our office in Boulder, Colorado. And this is my colleague, John Jones.
Hello.
Together, we're going to be telling you about some of our experience using cell widgets. First, a little plug. We're hiring. We work on the Google Groups product. How many people have used Google Groups? Okay, so you may not have known, but Google Groups is actually entirely, the front end is entirely written in GWT. And so it's one of our largest GWT applications at Google. Groups is actually a pretty massive product. A lot of times you don't know it because you're using it for a small, sports team or something. But we have hundreds of millions of users and hundreds of millions of groups that we support with the Groups product. And all the front-end work goes on in Boulder, Colorado, and we have some openings there for, especially for smart GWT programmers like yourself. So look us up. It looks like we're getting cut off in these images, so I'm sorry, I'm going to have to make an adjustment to the resolution because it doesn't look right. Not good.
Oh, yeah.
Let's try presenting again. So while this is loading, I also want to get a quick survey. How many people are actually using cell widgets in their GWT products today?
Oh.
Okay. And how many people are wondering if they should be using cell widgets? Okay, good.
How much overlap was there?
Yeah. Good question. Yeah, we're having some technical difficulties, so bear with me while we're loading these slides here. But let me just try and move on in the presentation. Basically, so for those of you who haven't used cell widgets or maybe you're considering using cell widgets, just want to review what cell widgets are all about. They're basically, okay, here we go. Cell widgets are intended to be these high performance and lightweight ways of rendering an interactive UI. So these are an alternative to the standard GWT widgets. And so they're great for making long lists like this where you have lots of items to keep track of. They can be spun up, these cell lists or whatever, pretty simply. You can invoke a cell list constructor, and then you provide it a cell, which is basically follows the flyweight pattern, and so this lightweight thing that gets stamped out multiple times in a long list like that. And then you add it to a display. I'm sorry, you add it as a display to a data provider, and then usually you add a pager to that constellation of objects in order to control things like scrolling. So I just showed you a list, but cell widgets can be used inside of tables and inside of trees as well. These are snapshots that I took from the GWT showcase, which you can find on the product, the GWT project pages. Really nice thing about cell widgets is they can give you direct control over the generated DOM. So here you can see how we can specify exactly the HTML structure that we want to use. This is something that you don't always have such tight control over when you're using standard GWT widgets. And they also give you this direct control over event handling. So here you see we have something that is intercepting a browser event. And you get some really low-level information, like the element that was clicked. You get the native information and native events, and you can do what you want with that event, but you can get information like the type of event. In this case, what we're doing is we're toggling a value once we decide that the click was actually in the right spot on the cell. So cell widgets can be awesome, but like in the Spider-Man comics, with great power comes great responsibility. And a lot of times, a lot of boilerplate code, like you might not have been too impressed with that last slide with all the stuff you had to do just to handle a click. And there are surprisingly complicated tricks that you need to do to access specific DOM elements in cells. This is probably the biggest thorn in our side when we use cells, and especially when we try and sell it to our colleagues who are used to using regular widgets. But they are used a lot at Google. I actually did a little audit just before coming to this conference and found that across all of Google code, we were instantiating over 100 cell lists and hundreds of cell tables and even some cell trees as well. So this is actively maintained Google code. I came up with the idea for this talk originally because there's actually, I think, a lot of lessons, some of them kind of hard-won lessons that we've learned creating code like this that uses the cell widgets. We're using them now in groups code that we're writing. I also use them when I was working on Google Drive. And so we have some war scars. And so here's some strategies that we've learned from using cell widgets in production-grade code that I wanted to share with you. So first is avoiding string building for more maintainable rendering code. Using filling and prefetching to provide more flexible and performant scrolling. Custom key handling for giving users the control that they expect with their keyboard. And composition utilities for creating composite cells in a more concise way. So you remember I said that a couple of those screen snapshots were from the GWT showcase. What we did was to kind of show off some of these strategies was we hacked the showcase and added some of the strategies into them. All the changes that we made can be seen on our on open source GitHub repo. So you feel free to hit that and see the diffs from the original showcase to what we have now. One of the changes that we made here, you'll see, is we added so this is the typical list demo, and normally has a scrolling area here, but we also added a me contact, a contact that represents yourself above the list. And then there's some bells and, some knobs and levers that we added to kind of show off some things. So avoiding string building. I love this picture, especially because of the little sign here. It says, not responsible for accidents. Accidents can happen when you start dealing with cell widgets, because you're often dealing with things at the sort of bare metal, more closer to raw DOM than you would normally use for widgets. So there's some tricks you might want to consider to make your code more maintainable. One thing to consider is instead of using what's used in the normal showcase, these appending of strings here, consider using SafeHtml templates. So with SafeHtml templates, you can have something that looks a lot more like a real DOM, a real HTML file, and then the curly brackets allow you to do substitution. And so this rendering code then gets turned into what looks like a piece of HTML, and then a small rendering call there at the bottom. Another alternative, especially as that HTML template gets bigger and bigger, you might consider splitting it into a genuine UI binder file. I'm wondering who does this technique, because it's kind of interesting. There's this thing called UI renderer, and it's just really poorly documented. It's kind of the secret thing, and I think in some way some places it's even labeled as experimental, beware. You can ignore it, as far as I can tell. I think it works pretty well. And it lets you have a separate file that you use to specify the DOM, and then the renderer code references that file, uses a reflection to figure out what name the file should be and so on. And then you pour in your data into that file there. So it allows things to scale pretty nicely. And there's even some nice support for event handling in the UI renderer, which can otherwise be a pain. And so while on the topic of maintainability, I also want to point out one thing that maybe isn't always obvious with the cells is that cells usually are illustrated inside of lists and tables and trees and so on, but there can just be one cell inside of one widget. There's an object called, there's a class called cell widget that's used for this. This can be used when you just need, when you need just to stamp out one thing, like we have in that me, that me entry here above the scrolling list. We use the cell widget to do that. And the nice thing when you use that cell widget class is that you can reuse the same cell code for rendering and event handling in this part of this of your UI as well as this part. Okay, so I want to move on to filling and prefetching. This is names we've given to techniques to give you more flexible and performant scrolling. Because for us, at least, the whole reason we're using these cell widgets is really to put them on a big virtual page and let the user quickly browse through stuff. In the real world, data is asynchronous. And the way this typically works with cell widgets is that you use you have a data provider that follows this API of the abstract data provider. And you're looking for what are called range change events. They're typically triggered by a user scrolling on the list. And then you get a new, get a new visible range. And then you'll typically fire off a request to your backend with that new visible range. And then you set up an async callback that then finally updates the row data and the row count for your cell list. For the purpose of the showcase, this was kind of left out. And I think it's an important, it's a problem in the showcase because the real value of cell widgets is in rendering large amounts of data, and you're not going to realistically have that data cached locally on the client. So in our hack, in the changes we made to the showcase, we made it asynchronous. So just to illustrate that, if I refresh this page, you'll see at the top a little banner that says RPC1. That stands for Remote Procedure Call 1. That's us going to the back end and requesting the first batch of data. And what we get back is 15 contacts out of what we think is a total of about 250. And as we scroll down, we're going to send off another remote procedure call, RPC2, that fetches another batch of 20 more contacts in this case. Okay, so this is much more realistic, I would claim. And you'll see that this actually is going to start stressing out the cell widgets or the cell list in some ways that are not pretty in the original demo code. And then we're going to show you how you can overcome some of those. So let me just start over. And I think the interesting thing here, too, is that, you can use cell widgets to make things as fast as you want. But if you don't have good strategies for dealing with the delay that you typically have in getting new data back from your server, the cell widgets it doesn't matter that you use cell widgets. You might as well have used tables or whatever in your GWT code. So the trick is to sort of marry some good strategies for filling and prefetching and so on with cell widgets to get a really high-performant list. One limitation that you'll see, and let me make sure I'm on the right page here. Yeah. Okay, so one limitation that comes up here once you add the asynchrony is that normally what you want to do is you want to make a reasonable first request to your server to get a bunch of data that's going to fill up the screen so the user feels like they've got something to look at. And typically what you want to do is avoid overfetching because you want to present that initial load as fast as you can, okay? So what we've done here is we've picked 15, we've arbitrarily decided that 15 contacts is a reasonable first fetch. The problem is that you don't know what's really reasonable because some people might have screens that are high resolution and show many more contacts. Or maybe they have a really big monitor, something like that, in which case your first fetch is just not going to do it. It's not going to fill up the screen. And in fact, the demo is even broken at this point because you don't even have a scroll bar. So you can't request a change in the visible range, which would request more data. So the showcase breaks at this point. But what we've done is we've added a checkbox here for supporting window filling, which is a strategy that we use to look after that first fetch to see how much of the available real estate, screen real estate, we've filled up. And if we haven't filled it, we'll go fetch some more. So watch what happens now when I have that turned on and I reload. You'll see there's RPC 1. And then an RPC 2 that continues then to get more stuff. This is also valuable when you've got the situation of, like in a mobile situation, let's say you have somebody with a tablet, and they're holding the tablet in, originally they're going to hold the tablet in a landscape orientation. Maybe it looks a little bit like this. And then at some point in their usage, they're going to rotate that tablet to portrait. Well, what's going to happen? Let's refresh, and we're going to fetch 15, which is good enough for the landscape orientation. But once we rotate, we've got a gap. But that gap is filled right away with the window filler because it realizes it has some more space to work with. That make sense? So let me just show you real quick how we do this generally. And all this code we're going to show you is we're going to be using ellipses for left out code and comments and so on. But if you want to see the full details of how we did it, please check out the GitHub. But here we're looking for two kinds of events from the cell list. One is the onloading state change, which tells us when it's got that first batch of data. And after that first batch, we call this thing called maybe extend after DOM is finished updating, which is to say, see if we can put any more in there. Similarly, the window filler is also a resize handler. So it looks at the resize events on the window. If that's been happening, then it says, oh, maybe this is another chance to do some more filling. And one thing we have to be careful about here is invoking that the extension code after the DOM is finished updating. Otherwise, you actually don't get accurate metrics on the cell list. That's one trick that we learned. So with the maybe extend method, then you're checking the height of what you've rendered, comparing it to the available height in the parent. And if there's some space, well, okay, then continue on here, and then we make a best guess of what's a reasonable amount of new stuff to ask for, and then we extend the visible range. So back to this demo. So one thing that maybe you might have noticed, which is kind of annoying in the original demo, is that you're only going to fetch data when the scroll bar gets to the bottom of the screen. So as I go down here, you watch. It's not until I hit the bottom that we finally see the RPC go out. Okay. So this is a kind of awkward user experience because it leads to this kind of stuttering. You get to the bottom, you wait a second, okay, and then you finally can scroll some more. This is an annoying thing that can be fixed with what we call predictive scrolling. So predictive scrolling is a super simple idea. It's just when I turn this on, you'll see that we're going to go ahead and start fetching new data just when you start getting near the bottom. Watch as I drag. See, it's already firing that RPC off Meanwhile, I could continue dragging. And so it leads to a much smoother scrolling experience for the user. We have about a 1 second delay on the RPCs, and I can barely keep up with my scrolling with even that. That's a pretty slow RPC, although it's not unrealistic for like a mobile device. So how do we do that? It's super simple. We just introduced this one little part in the code here, a fraction that we multiplied the scroll position, the max scroll position by. In our case, we're using a value of 0.7, which means when you get 70% of the way down through that scrolling region, go ahead and fetch some more. The user may never actually want to go there, but it's reasonable to just go ahead and anticipate that that's probably where they're headed. By the way, these numbers like 0.7 and so on these are the kind of numbers you're going to want to be tuning yourself for your own app. A lot has to do with your own particular performance characteristics of your back end and the kind of network connections that users have and stuff like that. Okay, so getting back to this demo, let me just start over. So even with this predictive scrolling at 70%, it's still not a great experience, especially initially. And that's because 70% of a small number is still a pretty small number. So when you have only 15 items, if I just whip the scroll bar down, I was easily able to get to the bottom before GWT recognized that we're past the 70% threshold and trigger the RPC. So another way of dealing with that is prefetching. So I'm going to turn that on and reload. So we do RPC 1. But notice it went immediately on to RPC 2. Did you see that? So it's basically a follow-up fetch that we're going to do just because we think, you're probably going to want it. And this kind of 1-2 punch here is kind of a classic design for a high-performant app, really. Get the minimum amount of data that you need, throw it on the screen, and in the background, go ahead and start fetching more. It's a technique that we use all the time. This can be done in a variety of ways. I know in our own app, we have a cache layer that we're not going to go into here. But with the cache layer, it can be trying to prefetch stuff and warm things up once it's active. And that's really what we do in our own app. But just for illustration purposes, here's how you could do it even without a caching layer. Again, you wait for that on-loading state change event. And then you can set a timer and say, well, after everything else is rendered, because maybe there's some reason that maybe the user's already scrolling and we're triggering the predictive scrolling and so on. So we'll give those a chance to fire. But if nothing else is happening, we're going to go ahead and call maybe extend, which that code is a lot like the maybe extend that I showed you before. It's going to do some more fetching if it seems like we don't have enough yet in our initial in what we initially retrieved. In this case, we're using this factor larger than viewport to determine if we've prefetched enough, and if we haven't, then we extend the visible range by that factor. So in the case of this demo, we're using a factor, I think, of 3. So that means that we're fetching 3 screenfuls of stuff in advance, just in case you might be heading down and going past 3 screenfuls. OK, I'm going to turn it over to John for the next part.
Right. So I want to talk about keyboard handling. Not such an issue for mobile, definitely for desktop. Power users, sometimes people using assistive technology will want to use the keyboard. There is a default keyboard handler built into the cell widgets. It looks good in the demo. It does a number of things. It does have some limitations. And one of the things is when it's going to sort of jump a page, it's going to try to if you let it increase the range, it's going to do it by a fixed size of 30. and you can't change that. It's private, it's final. They also disable the space bar, which is to keep it from doing the browser scroll, which in some cases could kind of mess up if the window is scrolling when you want to be in the list. But you can override that, provide an alternate handler. You can change those things. You can also do a bunch of other things that may be useful to make a really kind of good to use app. And so one thing we do is we use custom keys for use J and K for up and down. That's a specific thing. You may have other custom keys you may want to use. You can adjust the scrolling so that if you have, say, a fixed region on the page, and that's kind of floating, and you want to keep things from being behind it, you can adjust the scrolling to be aware of that. I'm going to show a technique for making the end key async aware. I'll explain that a little bit more. And you can also, if you've got rows that are shown but not interactive, you can skip those. And also, you can also do things with the rest of the page if that's something that makes sense in your application. So I'm going to switch over back to our demo here. I'm using the wrong key. And let's see here. So let me just refresh it, make sure I know where we are. And I'll show the default key handling, just that if I try to use a J and K, as you'd expect, they don't work. Also, I'm hitting the space bar here. Nothing's happening.
You really did press J and K, I saw.
That's right. That was not simulated. But of course, that's not really surprising. And now what I want to do is I want to go to the end. What did I do here? I got into the bookmark manager.
You want to do
that was a nifty trick.
Function.
Function command.
No command. Just function.
This works better with a keyboard with a real end key.
Yeah.
So it'll just function. That's it.
You need to select first.
All right. So we go back in here. We're going to show the end key. So what it does again, because we made this asynchronous and a simulated delay. What the end key did is it goes down to the bottom of the cell list as it's currently rendered. You can only go to an element that's actually in the DOM, and so it does that, but that triggers the scrolling, which triggers us to go back and asynchronously get more data. And if you see the scroll bar is nowhere near the bottom here. Now I can move on down, and there's lots more. But if I turn on the custom key handler, which we'll take a look at the code for in a second, it can handle that. Also, we'll show the end here. So what's going to happen is I'm sorry, I did page down. I'm not real good at this whole simulated end key. Here we go. Here's the end key. And what it did is it extended the visible range, basically asked for all the data, and then it waited till that came back, and it went to the actual bottom. And you see I really am down at the actual bottom. I can use the J and K to move around.
He's really using J and K.
And I'm going to try to use the home key back at the top, and I can use the space bar to I wired it up to page down, which I think is something that you may want to consider because it sort of makes sense. It's page down normally of the page. Now you've put it into the list. I think I showed all the. Let me see. Did I show all the techniques there? And custom keys. Oh no, one more. We got one more there, and that is also that if I go back to the beginning, I can also, if I'm going up, I go up one more, and I get to me. So this is an example of interacting outside the list. I've kind of made that somewhat seamless, but kind of kept it at the top. So code for this. First, we have installing the custom keyboard handler on your cell list when you set it up. One thing you may want to do when you do that is set the paging policy. Current page will make sure that you're in control of the visible range, meaning that the cell list will never change it itself. When it changes it itself, it does it again by a fixed amount. And there are a couple other values but you might find useful, but I find it better to directly control it. And then you need to implement the custom keyboard handler. And with that, you can extend the default one. This is the default one I mentioned before, and just override the cell preview. And in here, we're going to look at just handling the key down events. And when you handle those and return and bypass the default handler, but the focus and mouse events it also handles. It's not just a keyboard handler. We're going to go ahead and send those to the default so we don't have to override those. You can get into those as well, but I'm not going to cover that here. And so those key down cases, some of them like the down and the page up are like simpler versions of these other ones, but the up and K handling the same, and that go above list method is just going to take and put the focus up at the top and update the form. How to handle that when you get near the top. The wired up the space with like the page down, and also you can set your custom page increment. I've just got a constant here, but you could also do something like the window filler was doing, and you could do it dynamically based on the size of the page to make the page down make a lot of sense. And then the end we'll take a look at here is how to make that asynchronous aware. And so there, it figures out, hey, is all the stuff rendered or not? If it's not, it doesn't change the row yet. It extends the visible range and then waits. And I'll give you a second to look at that. And then when the data comes in, the loading of the loading state change event will come in. And the loading state means I've loaded all the data that you asked for. And again, we schedule it deferred to make sure that everything gets rendered because the event gets fired before that. And here we actually set the row at the bottom. And as you saw in the demo, it really goes to the very bottom. This is something you don't want to do if you have millions of rows. Obviously, it's like, does end make sense? You could also do a much simpler thing and say, hey, I do have millions of rows. I don't want the end. You could just disable it to keep it from happening. And one other thing here that ties in, not entirely the keyboard handler, is something we call focus drift. I'm actually going to go back to the demo here, and let me refresh to show what this is. And that is, if you aren't changing the row, but you are scrolling, when an update comes in, the cell list will put the focus back where it was after the update. So I'm going to scroll down, wait for an update, and now when it comes back, it jumps back. And I can do the same thing again. Well, I'm trying to scroll down to the bottom, but I've got to go back here. And now I jump back again. So if I'm trying to get to the bottom, that can be really aggravating behavior. And so what we have a way to allow the focus drift here. And now when I scroll down, we don't jump you. I can actually scroll a little faster than Chris, I think, here. And I can beat it and get to the bottom, but it's not jumping back on me. It was really nice. So I do that basically by wrapping the cell when we put it in the cell list, so that when the focus is put back on it after an update, we save off the old scroll position, let the focus happen, and then we put it back. So it's actually kind of doing it all quickly. The effect is it looks like it stays where you had it, and you can keep scrolling down. This does have a minor impact in that when you are using the keyboard to scroll down, as I was, say, moving the up and down arrows, this will disable that because the default focus handling is what scrolled it there. And so you can look, I'll back up here a second. If I look at this, rather than calling the set keyboard selected row directly on the cell list, I've just wrapped it with this little method called set current row. I don't have that, it's in the source code, but that's basically going to set the focus as well, to make sure that we broke it in order to make the focus drift work. We fix it again in the custom keyboard handler. Back to Chris here.
Okay, so strategy we wanted to talk about was composition utilities for creating more concise composite cells. Again, I'm just kind of curious about who's using composite cells. Does anybody know what I mean by this? Okay, so a few of you. So composite cells are handy ways of building more complex cells out of simpler ones. I'm going to turn this on to show you a slightly more complex cell. So you can see what we've added is, in addition to the normal picture, contact picture, name and address, I've added an @ symbol and a star. Both of those are hot. They're click targets that I can click on. So if I want to mail that person, I click on the @ symbol, and it opens up a new tab. And if I want to star this contact, I can do that, and it changes the color of the star. When you start getting into the ability to click inside your cells, you might start thinking about composite cells. And the reason is because with composite cells, you can have event handlers for each of those subcells that handle things like starring. And there's less work that you have to do to check that you've hit the right click target and things like that. The other reason of using composite cells is that GWT actually offers a fair number of useful built-in cells, like the text cell, SafeHtml cell, the image cell, image resource cell. All those things you can kind of mix and match inside of a composite to make something more complicated. Unfortunately, they often involve a lot of boilerplate code creating one of these composite cells. Maybe this is the reason why so few of you used it so far. It's a bit intimidating, the API. You have to first create these hascells things. A hascell has 3 important methods: get cell, get field updater, and get value. You have to implement each of those. Cell tells you what the actual nested cell is. Updater is used for updating the backing store. And then get value is how you transform the parent data type into another data type that's appropriate for the subcell. Once you define that hascell, then you provide that in the constructor to the composite cell. And you would also actually typically provide several of these hascells, otherwise it's not really worth using a composite. So you put them inside of an array to build up your cell. So if you think about that demo, my array is going to be 1, 2, 3, 4 long, because we've got basically 4 subcells that I'm using within each of those sections of that cell. Okay. And here it is applied to the context cell, that technique. So we're creating the array list with 4 items. Each of those 4 items is created using a static private function, and they return a hascell. So here you can see the first part of that, the create contact icon function. And it's filling out the required forms here, the get cell method, the get field updater, and the get value. So it's a bit of a pain, and that's just part of it, because I haven't even shown you create name and address and mail to and so on. Okay, but you can use utilities to make this simpler. So I've reduced all the code on that last page. Let's go back just to this one call in yellow here. And this is a utility function that we've come up with for our work at Google. Hascells has a factory function that takes a cell and a static value. In this case, we want to stamp out that same image everywhere. So we don't really care. It doesn't need to vary based on the cell data. So we're going to use this for cell with constant value utility function to reduce all of that hascell boilerplate down to just a single call like this. So this can keep things simple. And we have some other tricks in the hascell package like for adapted cell. For adapted cell allows us to transform proprietary proprietary data types to work with some of the standard cells. So in this case, this is creating the name and address bit, and there is this thing called SafeHtml cell, a standard cell that we can use in the GWT library, but you have to do this kind of data transformation stuff in the getValue method. But instead, you can use hascells for adapted cell and just provide a function that does that transformation, because that's really all that you need out of all its boilerplate code. So it can reduce the code for that as well. Then for event handling, if you're doing simple event handling, where you're not, say, updating your data store, example would be that mail to link, right? We're not changing anything about the contact when you send them mail. You're just going to navigating to a different part of your app. For those kind of simple event handlers, you can have a surprisingly large amount of boilerplate do something simple like that. So this is just checking that you clicked on that @ symbol that's rendered using the SafeHtml, using a bit of SafeHtml there. on browser event, we look if we hit the right click target, and then we call window open. And then we have the stuff that we're hardly even using here, the field updater and the contact. So if you don't really need most of that, why not call something like you can call our utility functions and reduce this even further. So you can create a cell for the mail to icon by using the adapt with constant value. I showed you that a few slides ago. Here, instead, we're using a text cell with a constant value being the @ So we don't need to vary that @ symbol for each contact. And then we use these hascell functions to wrap some click handling into that cell. And then you just need to fill out a really simple API, provided a receiver that has an accept method that allows you to do the click. So again, if we go back and forth, you can see I reduced that in half, basically. So these are just this is just a list of all the utility functions that we've identified here. Some of these come from our own work. Others we've sort of, after auditing some of the code that we've used throughout Google, I tried to pull those into here too. Hascell has these utility functions too. This is all in the sample code that we have on GitHub. So I just want to wrap up by just going over what we covered: avoiding string building, filling and prefetching, custom key handling, and composition utilities. And if this stuff is interesting to you, I also recommend you check out a few other resources. There's Leif gave already a talk about this. Vaadin has this really slick grid widget, which seems like it's going to be really high performance and nice to use. There's a cell composite with ID. And there's also Polymer core list, which is also a really fast list implementation. And just want to also point out that the web components, like Polymer, are things that actually mix and match pretty well with cell widgets, because they're all working at a low level of DOM, and so it's easier to do that than actually with regular GWT widgets. Yeah, let us know what you think about like some of those utility functions and classes that we identified in this talk, because it's possible that we could contribute them to GWT proper and make those available more generally. Oh, and did I mention that we're hiring? Boulder office, remember? Talk to me afterwards. Thanks.
You didn't mention the 300 days of sunshine a year.
Yeah, 300 days of sunshine. Any questions?